Hi, this is John Miskos from Tinker Electric. Today we're just going to have a short look at Tinkercad. So Tinkercad allows you to do quite a few things. So it allows you to make 3D designs, but the thing that we're interested in today is making circuits. So we can make circuits without the need for actual hardware. It's a great place to tinker around, to play around, to work out what works and what doesn't work. And it also allows you to start fleshing out your idea. So if you've got a particular idea, start making it here before you order the hardware. It's a great way it does save expenses, but it also saves some time because you see what's going to work and what's not. So what you can do after you sign up to Tinkercad, which is a free program, go to circuits, create new circuit, and from here, a good place to start, if you haven't already, is to start with the Arduino with Blink. So the first thing you usually do in hardware is make something blink. Why do you do that? Because it's a great way of understanding what the code is doing, what the electronics is doing. So I'll just give you a quick overview of what we can see here. We've got the Arduino microcontroller. We've got an LED with a resistor. So the resistor basically limits the current going through it. So we can talk about that at a later stage. And we've got the USB connector here. So if you don't have an Arduino already, this is a great platform. It's very versatile. I highly recommend it. I base all of my work around it because it's so simple and easy. So we've got two main buttons up here. We've got the code. So if we flick over to text, this is the code. It looks complicated. It's not. I'll break it down for you. And we've also got the simulation start button. So a couple things about the code to get you started. Basically, whenever you're using Arduino, there's a whole bunch of example code. So to start with, all that we're going to do is take from the example code, modify those, and do what you need to do. So you don't need to directly understand it. Eventually, over time, you're going to, but you can imagine as like an international language. You have a couple sayings that get you through the vast majority of conversations. So this particular code, what it does is it turns the light on and off. So this text is a comment. So comments are not executed. They're just for us to understand. So double slash is a comment and a slash star is a multi-line comment. We've always got this setup and we've always got this main program. Setup is run once, the main program is run forever. So what this does is it sets a particular pin. So these are all pins here. It sets it to an output so that it can turn on and off something. And this is just a short text for pin 13 is called that. And in the main program, so after it sets it up, then it runs the main program for forever. And what it does is there's only really two main things happening here, and it's repeated. So the thing about code is there's a lot of repeats in there. So what we have is we've got a digital write, which means tell it to go on or off, and it goes the pin that we want, make it high, so turn it on. And then there's something called a delay, so we wait. So in this, it's accepting a parameter that is in milliseconds. So there's 1,000 milliseconds to a second. So it says delay 1,000 milliseconds. This all that really says is wait 1 second. Then we've got that digital write command again. And it says that LED that we talked about before, turn it low. So turn it off. And then delay another 1,000, which is a second. So if we read this through, what happens is it goes, turn the LED on, wait a second, turn the LED off, wait a second. But then we turn and we loop through this again and again and again. So you can probably guess what's going to happen. It's going to turn the light on, off, forever. So let's have a look. on, off, on, off, on, off. So there's a couple things that we can do to play around with this. We can play with the timing. So there's the on timing and the off timing. So if we were to half the off timing, 500, so half a second, we can have a look what happens. You can see how it adjusts. We can also shorten the other side of that, the high. So now we're getting a faster flashing light. We can halve that again. And you can keep reducing that. So eventually you get to a point that your eye cannot perceive the difference between the on and the off. And that's just exactly how it happens in real life as well. So you can experiment, go off and experiment and see how fast you can actually make it before you can distinguish the difference between on and off. So this is just a short introduction to the code. The great thing about this is it can actually do a lot of things. So if we were to get rid of this existing example, here's another example, but using a ultrasonic sensor. We'll see whether or not the code came across. So this is the code. It's a little bit more complicated, but basically the same kind of principles apply. We won't go into that particular code, but I'll just show you that it can actually be used to do a few interesting things. So in this particular code, we've got an ultrasonic sensor, and what it's doing is it's feeding into the Arduino, and it's going to be giving us a report about what it can see. So in this particular case, the ultrasonic sensor actually detects how far something is away from it. There's a field of view. So just like your eye, you can't see behind your head, the ultrasonic sensor can't see a certain angle away from itself. We've got something called the serial monitor. So this is basically our ability to display text to the screen. So if we move this object around, we can see that it detects how far away it is in a different range. And then if we move out of that range, it doesn't know where it is, and it thinks it's beyond its sight. But if we move back in, there it is. So this is one of the components that we use in the Jack-O-Lantern project. It allows us to detect how far away someone is, and from there we can keep adding components like lights and sound to do different things. We basically use code to glue it all together. So have a little bit of an explore with Tinkercad, and I'm interested in to see what you make.